Hello, MBC kids. This is Miss Orloff, and I'm going to do a quick video on 11.5. So you had a discovery activity, and in the calendar for Monday, you should have seen this summary to talk about the unit tangent vector and how it tells you how you travel along the curve, the principal unit normal vector, and that's telling you how the tangent is changing and turning. So it always points toward that concavity, towards that center of the osculating circle. And you also know that t is perpendicular to t prime because the magnitude of t is 1, which equals a constant. And there's a little bit more that you should be looking at, like the binomial. The unit binomial is t cross n, and the TNB framing reference set of axes for a point in R3 moving along R of t. You can also, when you're graphing in a 3D plotter, click on the TNB. If I have time in this video, I will definitely show that. So again, this is something that you should review. Everything here, that's just a summary, and I am going to go ahead and start with an example. Okay, so I'm going to go ahead and go through an example here in a moment. If you hear the background noise, my neighbor, just didn't realize I was recording and thought it'd be cool to mow his grass while I'm recording. In any case, here's my example. If r of t equals sine 2t, cosine 2t, and t, we are going to find the TNB for t equaling pi over 6. So first thing we got to do is we have to go ahead and we have to find r prime. So here's r prime. And because you guys were all awesome BC students, I'm confident you can quickly get through this chain rule derivative and you find your r prime. The next thing I want to do is find t. And t is simply r prime over the magnitude of r prime. So the magnitude, I know when I square this component and add it to that component, I'm going to get that cosine squared 2t plus sine squared 2t. So that's just going to be 1. But then the 2 squared plus the negative 2 squared is going to give me the 4. So I'm comfortable just putting that 4 here for the magnitude, and then 1 squared is 1. Pretty quick. And then I'm just going to go ahead and rewrite r prime. All right. And then if we want to think about this at t equals pi over 6, hopefully you guys remember your right triangle trig, and you get 1, negative root 3, 1. And hopefully I remembered my right triangle trig and I have no simple mistakes, but I'm sure if I do, one of you will call me out for it. Okay, so the next thing we're going to do is go ahead and find t prime. Obviously we want to find t prime, not t prime at pi over 6, or that's just 0. So we're just finding that defined for all t. So I'm going to pull out that 1 over root 5, and I have negative 4 sine 2t, negative 4 cosine 2t, comma 0. All right. And now unit normal. I probably should have my vector notation being a little sloppy there. I have t prime over the magnitude of t prime. So for both of these, when I think about t prime, I know, oops, I accidentally hit my cap. calculator. So that's going to just load in the frame. Let me go ahead and turn that off. If I go ahead for t prime, in fact, have that factor of root 5, 1 over root 5, well, the same thing is going to be true for the magnitude if I took the magnitude. So I'm just going to, hey, pull out and say, let's just call that a 1. All right. And so then I'm just going to rewrite all of this stuff. And I am now going to square this term and this term. Again, we got that Pythagorean identity, and I'm going to be left with 16. All right, sorry for that long pause. It's been a while since I made a video, and I thought I had turned the video off. Okay, so nice and ugly. In the end, we are just going to end up with n equaling this. And I'm hoping you see that algebra. Don't want to forget my 0. And you would hope we're done, but we're not, because we still want this when t is pi over 6. And when we get that, here's what we get. Fun fact, or I shouldn't say fun fact, I should say important fact. Our double prime only gives direction of n if the magnitude of r prime is constant. Okay, so the next step is to find the binomial, and we must cross t and n. But before I go ahead and cross those two, I've got to ask you, why would you do that when you can easily do this? Say, look, I'm going to take the tangent at pi over 2 and cross it with the normal. I'm sorry, I said pi over 2, pi over 6. Cross it with the normal of pi over 6. So wouldn't this just be a better method of finding the binomial? Let me just go ahead and write this out quickly, and you guys can pause the video and do the cross on your own. And there you go. I found my binomial. Okay, so here's a tougher problem. And so we're going to have r of t is 2 cosine t, 3 sine t, 0, and we're going to find TNB at t equals 0. So what I'd like you to do is pause the video and find r prime and then the magnitude of r prime. Okay, I would love for you to pause the video and check your work against mine. R prime was easy. The magnitude of r prime, not so great, because I get a cosine and a sine, and you can see me using my trig identities to make that just a little bit prettier. All right, so since I've already shown one example, I want you again to pause this video and find t at t and then find it at 0. All right, so if you've done your work right, you see that you get t of t, and then when plugging in 0, you're going to have to know your right triangle trig, and you get 0, 1, 0. All right, once again, pause the video and find t prime. This is not fun, and here's why it's not fun. For each component, I'm thinking I've got some issues, right? Like I've got to go ahead and think about how I may have to do a quotient rule. But in any case, I'd like you to try on your own. All right, I'm going to walk through this one because I think this could be a challenge for some. Just thinking about your calculus and just it's kind of obnoxious. So if you were in my class last year, you know we sang a little bit of a song, low D high minus high D low, square the bottom, and away we go. That's what we're going to do. So low, so we're going to leave that alone, times derivative of high, so we're going to take this derivative, and that piece should not be bad. Minus high, derivative of low, that's a chain rule. And so let me think about that chain. I've got 1/2. Leave my inside alone. I've got to deduct that 1 times the derivative of the inside, which is a multiple chain. 2 times 5 is 10. I have cosine t times the derivative of cosine t. That's horrible. Okay, now that I have that, I square the bottom, and away we go. All right, but we want this at 0, and that's what's going to make this a little bit better. So go ahead, plug in your 0, find your t prime of 0. All right, there we go. The above step is ugly, and this one's not so bad. So now what I'd like you to do is take some time and figure out the rest of the problem. Meaning I want you to pause the video and see if you can find n at 0 and b at 0. All right, there you go. There's the end of this problem. I hope that helps, and if you have any questions, just let me know. Have a good day.